Alright, here we go on chapter 14. Experiments learning in animals sometimes measure how long it takes mice to find their way through a maze. The mean time is 18 seconds. Researchers think that a loud noise will cause mice to complete the maze faster. She measures how long 10 mice make with noise and stimulus. The mean time is 16 and a half. The null hypothesis for a significant test. So remember, the null hypothesis is what you assume is true, and the alternative is what you're trying to show is true or what you think might be true. So what do we assume is true? We assume that the mean time is 18 seconds. That's the null hypothesis, and we're trying to show we think it might be faster, so that would be less than 18. So the null hypothesis would be it's equal to 18. Okay, 33. Use software to carry out a test of significance. Program tells you that the p-value is 0.031, so the p-value, that'd be 3.1%. What does that mean? Well, what that means is if h0 is true, let me get rid of this guy, then the probability of getting a sample as extreme as what we got is 3.1%. Okay, so remember that would be if we looked at the sampling distribution. Because we're assuming h0 is true, that's mu sub x bar would be mu, whatever that is. So that then our sample, say x bar, would be over here, and then the p-value is this over here, which would be 3.1%. So that's a probability that we get a sample, remember we're talking samples here, further away than our value of x bar. Okay, so more extreme, so that would be this. And of course we're always assuming that h0 is true. That's our assumed innocence at first. Okay, 40. Exercise 1434. Describes a class survey. Students claim to study. Average of x bar is 137 minutes of study time on an average night. And on 1434 it says the standard deviation is 65 minutes. The population is 65 minutes. And study time is normal. Okay. So we got first year students at a university. It's an SRS. So we got a sample, random sample. We got the population is normal, and we know sigma. So those are our conditions for doing a test. Does the study give good evidence that students claim to study more than 2 hours a night on the average? So H0, we're going to assume it's 2, and we want to know, do we have evidence that mu is actually greater than 2? Well, the conditions are met. Okay, so in this case it was sigma is known, study time is normal, and it's a simple random sample. And then the test statistics, or test statistic z, that's this right here. If mu really is 2, then sigma is going to be 65 over the square root of, what was our sample size? 269 from the problem from 1434. And we got 137 minutes, which is over here somewhere. So 137 minutes. Now we got to be careful because we're talking hours here. So, and this is in minutes. So 137 minutes. We're going to have to convert that to hours so that we can use the same units. This is minutes and this is hours. And this is 65 minutes. So I could just write this as 120. We're talking all minutes now. So we're okay. So z is going to be 137 minus 120 over 65 over square root of 269. Okay, so, and that's going to be my p-value right here. The probability that I get 137 or more extreme. So I'm going to go ahead and do this test on my calculator. So it's going to be, well, tell you what, I'll pull this up and we'll do it on the calculator this way. How about that? So I'll move it over here. So we're going to do stat tests. Oops, I gotta do it this way. It's a z-test. We're putting stats, data in from summary statistics, not data. So mu 0 is 80. I wrote 2 up here thinking it was hours, but we better switch this to 120 and greater than 120 because we're talking minutes now. So 120, sigma is 65 minutes, and x bar is 137 minutes, and my sample size was 269. And this is mu, we want to know that it's greater than 120. So greater than mu 0, and so calculate. Okay, so z is going to be 4, hitting the button there, sorry. 4.29 and the p-value, sorry, once I write on the screen the calculator goes away. 8.9 times 10 to the negative 6. You see that e there on the screen? That's going to be 1, 2, 3, 4, 5, 8, 9. So I moved the decimal over 6. 1, 2, 3, 4, 5, 6. Okay, which I'm not going to leave there. Okay, so that's this. So this is really not likely to happen by chance for me. If the average is 120, for me to get 269 kids to have an average of 137, highly unlikely, but it did happen. And so since this did happen, the only thing that I assumed was that the average is 120, so that makes me really question that 120. And so I can say since the p-value is less than 5%, that's my cutoff for considering something extreme, I have strong evidence that the average number of minutes studied per night is greater than 120. I don't know what it is, but I just know it's greater than 120, or at least I have evidence for it. See, I'm not proving it, I just say I have evidence for it. If I want to know specifically what it is, then I would do a confidence interval. All right, there you have it.